Today we're going to be talking about isosceles and equilateral triangles. Okay, we briefly talked about these before. Okay, but we're going to go over again in more detail some things about isosceles and equilateral triangles. Okay, so on your note sheet, hopefully you're on the front side where it says isosceles and equilateral triangle notes. That's where we're going to start. Okay. So the first thing we're going to talk about are the parts of an isosceles triangle, okay? The isosceles triangle, remember, has how many sides the same length? Two, at least two, right? So we have some like special parts or special names when we have an isosceles triangle, okay? So the congruent sides, the two sides that are congruent, we call those the legs. Okay, so fill this in on your note-taking sheet. The congruent sides are called the legs of the isosceles triangle, okay? So that side AB and that side BC, those are the legs, okay? Okay, now, the non-congruent side is called the base of the triangle, okay? So fill that in. The non-congruent side is called the base. So AC would be the base of your triangle. Okay, now you guys have like a little diagram there on your paper. So if you need to, you can actually make some marks on it. Like this side here is a leg, right? This side over here, this is a leg. And then this part right here, this is your base. Okay? So if you need to mark those things on your diagram so you have a clear understanding of which part is which. Okay, so does anyone need any more time labeling the vertex or the base? Remember, the vertex is where the two legs meet, okay, and then the base angles are the two other angles that are attached to the base. Okay, anyone need more time here? Okay. All right. Okay, so now let's take a look at what the isosceles triangle theorem says, okay? The isosceles triangle theorem says if two sides of a triangle are congruent, so if we have an isosceles triangle with two sides congruent, then the angles opposite those sides are congruent, okay? So if we are given, for example, in this diagram, that side JK is congruent to side LK. So let's actually, you can mark those sides congruent in your diagram if you want. Then what this theorem says is it says that if those two sides are congruent, okay, then that means that the two opposite angles are congruent. So the two opposite angles of those sides would be angle J and angle L. So then we can also mark those congruent as well. Okay? Now, how do I know where the opposite sides and the opposite angles are? Well, if I take the side and I go straight across from it, that's where its opposite angle is. Does that make sense? So if I have these two sides congruent, then both of their opposite angles are going to be congruent. Okay? Does that kind of make sense there? All right, how many of you guys need more time writing stuff right there? Okay, let's take one more minute. Let's take a look at some of the example problems we have here, okay? So we have here that on number one you have those two sides congruent, right? So if you have those two sides congruent, what do you also know about the opposite angles? The opposite angles must be what? Congruent, right? Now let's look at where the opposite angles are. That would be here, this one, R, and then this one over here, Q, right? So what I can do, and what I want you guys to do, is mark them that they are congruent on your page, okay? So if those two angles are congruent, what can I also label this one right here? 2x, because it's the same size, right? Okay, now it's asking me to find x. So going back to what we learned last week, what do I know that all the angles in a triangle always have to add up to? 180. So now can I set up an equation to help me solve for x?
Sure.
Yeah. So my equation would be 40 plus 2x plus 2x equals how much? 180. Okay. So let's go ahead and solve this now. So I get 40 plus 4x equals 180. Then I'll go ahead and subtract. Okay, and now let's go ahead and divide 140 by 4. So what do we get for our value of x? Yeah, x equals 35. Okay, and so that's my answer. Okay, are there questions on how we did that one? Okay, all right. So now let's take a look. I want to also take a look at, because we're not going to have time to do every single one of these, but let's take a look at number 4. Okay, so everyone really quickly take a look at number 4. Okay, on number 4, you have two triangles in number 4, right? Okay, we see that in the bigger triangle, we have two sides congruent, so that means they're opposite angles. These two are going to be congruent, right? So I'm going to go ahead and I'm going to mark their opposite angles congruent, okay? This one is congruent with this one right here. Okay, since those two angles are congruent, what can I also label this angle right here? Yeah, 6x plus 6. Okay, now what I would like to do is I'd like to take the three angles in this triangle and I would like to add them and set them equal to 180. But I'm still missing this angle right here. Okay, well, what do I know about that angle related to this angle over here? Are they congruent? Are they formed by two intersecting lines? What kind of angles are those? What is that called? Opposite angles formed by two intersecting lines. Vertical, okay? So because they're vertical, this one here is congruent to this one here. So what can I also label this one? 2x. Does that make sense how I got that? Okay, so now that I've labeled that one 2x, okay, what can I do? Do I have all three angles in that blue triangle that I highlighted? Yeah. So let's go ahead and add together all three of the angles in the blue triangle. So I'm going to have 6x plus 6 plus 6x plus 6 plus 2x equals how much? 180. Okay? So how many x's do I have? What's 6 plus 6 plus 2? 14. Okay, now my regular numbers, I just have 6 plus 6. So that's 12. And then last, I'm going to go ahead, let's subtract. And then divide. Okay, so what do we get for our value of x there? 12? Okay, so there's your final answer. Okay? All right. Okay, I want to do one more with you guys. I want to do, which one do you guys want to do? Do you want to do 3 or do you want to do 6?
3.
3? Okay. All right, so let's take a look at number 3. Okay. Number 3, okay, you have 2 of the sides congruent, right? So if 2 of the sides are congruent, remember, you can take the angles opposite those sides and mark them congruent, right? So I'm going to be able to mark angle Y and angle Z congruent. Okay, so this one congruent with this one here. Now, if they're congruent, I get to label them the same thing. So what do I get to label angle Z? 3x. Okay. Now I have all 3 angles in the triangle. So what do all 3 angles in the triangle add up to? You could add them all to 180, right? Or you could do the shortcut, because what kind of triangle is this because of this symbol right here? It's a right triangle, so what is the shortcut? The shortcut is the remaining 2 angles equal what? 90 degrees, right? So I could just do 3x plus 3x equals what? 90. That could be my shortcut. Or I could have done 3x plus 90 equals 180. Either way, I'm going to get the same answer for x, okay? So I'm going to solve this. I get 6x equals 90. And so what do I get when I divide by 6? 15, okay? All right. Are there questions there on that part? Okay. All right. Even though we didn't do them all, we'll save some of the other ones for warm-up. So what I want you guys to do is flip over to the back, okay? And we're going to move on to the next part, okay? All right. Okay, so on the back, we're going to talk about the converse to the isosceles triangle theorem. Okay, the converse is basically just saying that this theorem works the other way around. Okay, so the isosceles triangle theorem said if you know the sides are congruent, then the opposite angles are congruent. Well, the reverse of that would be saying if you know the angles are congruent, then the sides opposite of those angles have to be congruent as well. So it's like backwards. Okay, instead of starting with sides, now we're starting with angles, and we're saying it works the other way around. Okay, so if we're given, for example, in this diagram, that angle J and angle L are congruent, then what we can conclude, or what we can determine, is that the sides opposite those angles are congruent. Okay, so that would mean that we would have side, let me fix that, side JK would be congruent to side LK. All right, that would be our conclusion. Okay, so take a minute to write that stuff down. Okay, do you guys still need more time there? Okay, what I want to do right now is I actually want to go back to example 2, because example 2 on the other side is like an example of this converse to isosceles triangle theorem. Okay, so everyone take a look really quickly at example 2. In example 2, see how you're starting out with two of the angles being congruent? So what we can say, because these two angles are congruent, is we can say their opposite sides, which would be these two, are also congruent, okay? So if those two opposite sides are congruent, I want you guys to mark them congruent on your page. Mark little tick marks there showing that they are congruent. Okay, so now that we know that these are congruent, what can we do with their two measurements? Set them what? Equal, okay? So I'm going to say that 3x minus 6 is the same length as 2x plus 6. Okay? And so now I can go ahead and solve this equation by subtracting x and then adding 6. And so what do I get from my value of x here? 12. Okay? So there's your answer there. Okay? All right, are there questions on that one where we started with the angles and we made a conclusion about the sides, so that's why we set those sides equal? Okay? All right. Now, last, I really quickly want to talk about some special properties of equilateral triangles. Okay? So let's take a look at the back side at the part we have on equilateral triangles. Okay, so if a triangle is equilateral, then it's also equiangular. We kind of talked about this before, right? If all three sides are equal, then all three angles are also going to be equal. Okay, so making it equiangular. Okay, if a triangle is equiangular, then it's also equilateral. So if we know all three sides are congruent, we can say the angles are congruent. If we know all three angles are congruent, we can say all three sides are congruent. Does that make sense? Okay, so an equilateral, equiangular triangle, they are like mutually exclusive to each other. If one happens, the other has to happen, and so forth. Okay? All right, so the last thing about equilateral triangles, okay, is if a triangle is equilateral, then every angle has to measure 60 degrees. Okay, it always happens that way. There's no other possibility for the measurement of the angles. If they're all going to be equal, they all have to be 60. Okay? All right, does everyone have those things filled in? Okay, so let's do one quick example together on this. Okay, let's do number 2. Okay? All right, so take a look at problem number 2. You have an equiangular triangle on problem number 2, so that means it's also going to be equilateral. So what you can do is mark all of the sides congruent. So everyone take your pencil and mark all the sides congruent. If you have all sides congruent, you're allowed to set them equal to each other, right? So we're going to say that we have 6x minus 5 equals 5x. Okay, now we're going to go ahead and solve this. So negative 5 equals negative 1x, and then divide. And so what do we get for our value of x? 5. Okay? All right, are there questions on that one? Okay, that's about all we have time for as far as examples today. Okay,